Chapter 8, Utilizing Available Technology. Our objectives: describe how technology can produce higher levels of health and safety. Describe some safety improvements that have evolved since the introduction of newer technology in the fire service. Explain the problems that can arise by over-relying on technology. Discuss the use of technology in improving the medical monitoring of personnel. List the ways technology can be adopted from other industries to reduce injuries and deaths from motor vehicle crashes. Explain the theory of using time, distance, and shielding to prevent injury. Discuss the design aspects of simulators that are necessary to improve training systems, and describe the application of robotics to improve safety. It's important to note that change, especially in the fire service, can be difficult. And when it comes to firefighting, some argue that you cannot put lives on the line with technology because it can fail. And technology is flawed because humans are flawed, and of course we make the technology. However, ignoring that technology can be responsible for saving lives in the form of such things as enhanced 911, vehicle airbags, and carbon monoxide detectors is not fair. Technology is the most appropriate use for safety in conjunction with training and a little common sense. When we rely exclusively on technology, we do set ourselves up for failure. Fire tactics change based on research and technology improvements, and commanding officers must be familiar with these developments to make proper decisions. One good example of this, many of you that have been in the fire service for any length of time understand the concept that when we went through fire school or recruit school many moons ago, we were always taught, don't attack fire from the unburned side. You'll push the fire and burn the whole house down, or have competing streams and things of that nature. However, with Governor's Island experiment, we've actually learned that you really cannot push a fire with the hose streams. And the reason that the fire would move or spread more than likely has to do with the air currents and door control and things of that nature with ventilation. So it's perfectly acceptable, scientifically speaking, and backed up to say, okay, here's this house, it's on fire, and it's confined to the AB corner. I can see it venting through the roof. Go around and start attacking it from the AB corner from the outside, knock it down, do an indirect attack, if you will, and then come around, go through the front door, make a left, go down the hallway, and then extinguish the fire after conditions have improved. And with today's modern construction, that's probably the safest thing to do with the tighter insulation, the potential for smoke explosion, backdrafts, and the fact that these fires are extremely hot now with this modern construction, and it's more ventilation fed than fuel fed. That's just a safer way to go about doing it. But that requires us, especially the individuals that have been in the fire service any length of time, to change our mindset, to come up, realize and accept the scientific data and the trends and change what we have done. You always have those people that say, I've done it this way for 500 years and it's always worked. Well, yeah, that's great, but what about the one time it doesn't work? What about new trends? So definitely stuff to keep in mind as we're going through this chapter. Now, before we start doing the praises of technology, there is such a thing as over-reliance on technology. An example of this, in 1995, the National Transportation Safety Board blamed the lack of single system integration between the highways and the railway systems for railroad crossing, and for that reason, there were a lot of school buses being hit by trains. A similar hazard exists in many areas of the country for emergency responders. Now, technology has allowed many towns to obtain traffic preemption systems, allowing an emergency vehicle to change traffic signals to green as it approaches. Unfortunately, the technology intended to increase safety can actually increase the risk in certain traffic situations. Basically, collision with other vehicles. Another potential problem is the response of multiple emergency vehicles, and then, of course, collision between units. So, looking at this red light system, you got a fire truck pulling out of the fire station, they hit a button and all the lights are supposed to change green, or they have electronic sensors that change it green. Well, when the light suddenly changes from green to red, then you run the risk of other people, slamming on brakes, rear-ending, things of that nature. Or again, if you have competing emergency vehicles going to a similar call and taking same routes, well, yeah, you run the risk of them running into each other. So, with them relying on the light being green and nobody else coming. So definitely stuff to keep in mind. And I think this falls under that whole little common sense clause that we saw earlier. Utilization of technology. Now, Initiative 8 has the goal of consolidating all available technology in any application that can raise the level of health and safety. So that should be one of our initiatives, or rather is one of our initiatives, one of our focuses moving forward in the firefighting field. Now, there are 4 specific ways we can get a glimpse of the direction in which we are heading. And this is looking at your present needs, current trends in the industry, military applications, and statistics. And we'll go through each one of these here. Now, most companies that design new technology for a profit base their research on specific needs. Consumers have to be convinced there is a need for that product and that it's sold at a fair price to make a purchase. It is also important to remember that a primary goal of advertising is to convey to you a need, whether you really have one or not. So, your example here would be the luxury car commercials that you see during football games, vacations, things of that nature. Now, fire and EMS equipment advertisers are no different. And advertising sometimes displays unsafe acts as heroic and, of course, further ending the safety culture. But when we're looking at such things as technology in the fire service that's coming out, what about thermal imaging cameras? And when we look at these TICs, these thermal imaging cameras, they've come a long way and they've become more or less cost prohibitive, and you see more units having 1, 2, or 3. Well, that is a good thing, right? Now, what about the new bells and whistles with your thermal imaging cameras that are now in face mask for your SCBAs? Is that something you need? And you can argue it yes and no. From the standpoint of no, we really don't need it. Only one person needs to have a tick. They can communicate, blah, blah, blah. Is it nice for everyone to have a tick? Absolutely. Is it nice to have the whole heads-up display and the mask to show you the heat? I would say so. But, again, do you really need it? And is that something that you're going to spend your money on? So, that's just something to think about when you're looking at your present needs, especially within the fire service. And here's an example in the text when they're talking about present need. The example in the text, they use equipment for down electrical lines. Of course, years ago, departments carried hot sticks or rubber gloves to move them, and today live power lines are, of course, left to the professionals. So, is it something that's just a fad, or is it something that you're actually going to use and need? Now, a portable piece of equipment that could safely cut, isolate, or interrupt power flow from a dangerous wire would be, I think, a welcome tool in the fire safety field. So, if you got any ideas, here's your chance to make some money. Another way technology is introduced is to address current trends, such as like going green, using better firefighting foam that's more eco-friendly, things of that nature. And new technology has a potential if it is, environmental friendly and sustainable. Now, the trickle-down effect refers to responding to emergencies with such things as hybrid cars, standby generators, solar wind power buildings with engineered trusses, and things of that nature. Now, a current trend, especially in the fire service, is to push to improve safety, such as better air management or improved accountability. Now, examples of additions to the past devices and PPE is automatic distress single units, and that's something new that's out there. But it kind of operates like your similar pass device, but it's a better way to give location in terms of GPS and things of that nature, so that the RIT teams can find you more quickly. Military applications will always have significant influences on the technology that the fire service use, as well as NASA and the Department of Defense have bigger budgets and the ability to research new technology at a level not attainable by the fire service. So it is vital for technology adopted from other agencies, of course, to be tested in our environment and have some standards to use. But I find it interesting that if we look at the military and trends, they're always doing things, and I think it's a lot because they're not as regulated, but coming up with better ways to do things, and then of course that trickles down to other non-governmental type industries and entities. So, for example, you can look at the military, and the military started using clotting bandages first, for example, for bleeding control and tourniquets. And, all the studies that were done was showing that this stuff was working. So it transitioned into EMS where, hey, let's start using these clotting bandages, packing wounds, and going back to tourniquets because it's not really as bad as we had thought in terms of the EMS world. Now, one of the more recent crossover applications from the military, of course, is our thermal imaging. Now, other technology adopted from the material, as I said, include your field trauma treatments, some protective clothing, satellite photography, and other hand-me-downs from the armed forces. And, of course, that will continue to benefit from everything that they learn and do. Looking ahead at what the military is using gives us a good idea what we might see in the future. And here's an excellent example of this. Drones. The military is using drones, and their technology for drones is out there, and we can, of course, see how everybody has drones as a hobby, kind of like the old model airplanes or boats, things of that nature. Well, now, the idea and the thought is start using drones to do your 360. So you're the incident commander, you get on scene, you crank the drone up, you got the camera, you can get a real bird's eye view or street level view all the way around a building, a structure, or say a warehouse that could be quite quicker than walking around yourself or possibly driving depending on the size of the structure. Another example of drones being used, I saw it the other day. It was a drone that carried an 1.75 inch line with a smooth bore nozzle on it up like, I want to say 7 stories, and began pumping water into the structure. So, high-rise applications. A drone is, of course, uh, less costly than, say, a ladder truck. And of course, if you can fly it up there and get the same job done, rather than put people in harm's way, that's always a good thing. Another example of drone usage that's in the industry right now, and I saw this in Europe, and these people were using this, it was from grad students as a part of their thesis, but they wanted to do AEDs. And it was the greatest thing I saw, where you had a drone that was basically an AED. You call 911, they find out it's cardiac arrest, the drone gets launched from nearby whatever. Then you have a pilot at the 911 center that guides the drone to the location, lands the drone, and then the person comes out of that location, grabs the AED that the drone carries, and begins to use it to help with timed defibrillation. So, hey, that may be a possibility with drones today. So, excellent ideas for the future. Course, now when we're looking at hard data, statistics. And this is the last way to introduce technology. And of course, you start looking at the numbers and evaluations, and they say, they'll say numbers don't lie. So unlike needs or trends, statistics do not take opinion into an account. Now, a realistic example is the technology research being conducted by the Worcester Polytechnic Institute as a direct result of the line of duty deaths of 6 Worcester firefighters in a warehouse building in 1999. The WPI is developing a system that prevents firefighters from getting lost in a building. Now, of course, the final system will likely be able to plot firefighters' location in a building on a 3-dimensional map in real time. So again, by looking at your statistics and trends, hey, we really need this because we had a fatality. And I hate to say this, but if you look at a lot of departments that have an in-line of duty fatality tend to benefit most from grants and things of that nature, or eligible for grants to prevent this from happening again. And I hate that one of our brothers or sisters has to die in the line of duty for this to happen. However, as I said, a good example of this was when T.J. Solomon died years ago, the city of Atlanta. The city of Atlanta got money from a grant, the fire department did, for a flashover simulator. And the goal was that to teach their firefighters, new and old, the dangers and the conditions leading up to a flashover. So by seeing what the smoke is doing, looking at the flames from an actual standpoint of being in there but doing it safely, and then seeing it flash, you can gauge in real life that, hey, I've seen this before, I've got the mental Rolodex, this is not good, I got to get out before it flashes. So again, an example of statistics, needs, and getting stuff. So now let's look at types of line of duty deaths. Now, tracking firefighter location inside a building is a technology that has been difficult to develop. We cannot look at any statistics in terms of saying that is the cost of doing business, as doing so causes missed opportunities that could save lives in the future. Now, the balance of this chapter takes broad classifications into account when it's looking at line of duty deaths and matches them with areas of promising or potential technology devices to help with that. So let's start looking at a few. Stress and overexertion. Now, technology improvements are a key strategy in reducing causes of line of duty deaths from stress and overexertion. And the way to do that is medical monitoring. Now, researchers in Indianapolis and Maryland observed firefighters at work while wearing medical monitoring, or basically what they call life shirt vest. And the technology also provides its ability to monitor the firefighters in the hazardous environment. So it is plausible that they could someday be integrated into all of our PPE ensembles. So real-time monitoring would rely on a separate component such as telemetry, which is already a part of structural firefighting in some areas in Europe. Some self-contained breathing apparatuses have the ability to communicate with the base unit at the entry point of a building, transmitting information about our oxygen levels, ambient temperatures, pass status. Another issue would be Indianapolis, especially for those people that live there, as I'm murdering that name, study. Some members volunteered for saliva tests in which cortisol, which is a hormone used to measure stress indicators, was evaluated and compared against an emotional state and mood survey that they completed. So stress in terms of the medical component is something that we deal with, of course, on a daily basis. And you can look at all kinds of studies, and when people in public safety, even just sitting and relax, say at a fire station in a recliner watching TV, their heart rate, resting heart rate, is already higher than their normal resting heart rate outside of work. And one of the premises of that is that, we're always on that sense of being ready, on the edge. So you're always kind of stressed in a sense, waiting for the tones to drop. So you always have that mainline little adrenaline, so you can be ready to go, of course, at a moment's notice. Now, another interesting study with medical monitoring was done over in Europe. And they believe that one of the reasons we as firefighters are having heart attacks and strokes after fires is because of the fact that we go into an extremely hot environment. And when we come out, you're actually really extremely dehydrated, and it causes your blood to thicken up. And the thicker it is, the more prone it is to clot. And of course, you get a clot in the small arteries of the heart. You have a heart attack. If it ends up in your brain, you'll of course have a stroke. And one of the things that they were studying about these firefighters, they were taking blood levels and readings and measurements prior to doing like such things as training burns, and prior to starting shifts, and then after real fires. And again, they were finding that the viscosity of the blood was a whole lot thicker than it was beforehand. And again, they're equating that to the high temperature. So how do we combat that? Do we work on overhydration? Do we make sure everybody has fluid IVs when they come out? Do we wear a cool vest perhaps underneath our PPE? So again, there are all kind of technologies out there, but it just needs to be adapted to the firefighting environment. So possible technology could be a computer that could look at the environmental data, equipment status, vital signs, and emotional stress, again, to help monitor things and pull folks out before there is an issue. The computer could then enter these into an algorithm against the firefighter's baseline to determine whether the firefighter should, of course, pull out, rehab, or be sent to the hospital. Now, this is a big pet peeve of mine, but rehab. The rehab criteria would take out many of the personal issues involved with rehab by requiring that a member return to a certain baseline before going back in. And that baseline that we're trying to come up with, everyone is different. Your heart rate, your pulse rate, respirations are different from other people. And trying to put a finger or a thumb on a specific number just doesn't work, in my opinion. So, what are their normal trends beforehand going in, and then, wait till they get back to that normal trend before going back in. And I really don't think we do a good job of rehab in the fire service and looking at our individuals and making sure they're good to go back in. Now, incident integration. The potential exists for monitoring personnel at the scene of an incident to an extent and not possibly before. Many departments use an accountability officer to assist in tracking interior crews and rapid intervention groups. But three-dimensional tracking systems would make the position a mandatory assignment. You know, that whole accountability officer, and a lot of times that accountability officer is also the IC, which is also the safety officer. Well, hey, in this day and age, especially if you got the resources, all three positions need to be staffed, and that way you're only focusing on one thing and you can have the full attention. Now, supervisors of tracking employee resources. Rather than counting bodies at rehab and asking who's ready to go back in to work, medical evidence would be coupled with how well the person feels to better, plan and use them effectively. Unfortunately, motor vehicle crashes are a big time hazard in the fire service. And I hate to say a lot of it is, when we are, responding to or coming back from calls. Now, vehicle safety compared to automobiles, the fire apparatuses and ambulances do not provide the same amount of protection you would expect. Custom emergency vehicles are engineered more to function and aesthetics than it is to safety. Now, a glimpse into the future of emergency vehicles will undoubtedly include more modern technology and improved safety requirements. We can expect more stringent requirements down the road, including crash worthiness testing, which is not done now on fire trucks or ambulances. Why? What about airbags? Have you seen a fire truck that has an airbag? And the answer is no. I don't know. I've never seen a fire truck that has airbags. I have seen an ambulance that had a driver and a passenger side airbag, but that's just because that the front of the chassis was a truck front that already had them in there. So why are our fire trucks not designed to take a hit? Why do we not care about the safety of the individuals inside? Are we less immune to an accident? Now, there are some changes. So, for example, when you're looking at ambulances, now, you have such things as lift gates, hydraulic stretchers, things of that nature, because they've shown that, hey, back injuries are very common in EMS and fire services. So a good way to prevent that is using hydraulics. So you're not wearing out, and these hydraulics are battery powered, you're not wearing out your people's backs, especially with, your obese or very large patients. Another interesting safety factor that's I'm hoping going to be mandatory soon when you start looking at design of ambulances, but many a time when we're working in the back of an ambulance, there are no restraint devices. So you're running around untethered to anything, and if the ambulance got in a wreck or rolled, then hey man, you're going to bounce around like a ping pong ball. The only thing that's really secure, of course, is the patient. And even that's kind of questionable. So, again, things I've seen that are coming out in the future is like a 5-point harness that is got a tether on it. So when the brakes lock on, the tether locks down, and hopefully it minimizes the movement of the rescuer in the back of the ambulance so they don't bounce around as bad. You've got that mesh netting that they put at the end of the bench seat. And the bench seat is, on one side or both sides of the ambulance is that kind of runs the length of the patient compartment. And of course, in the past, when you slam on the brakes, you would slide of the bench seat, and a lot of times there was just like a sharps container or a rail that we'd call a rip breaker, because you would kind of slide into it, and you would hit your side. Well, now they've said, hey, you know what, that's probably not the best idea to put that there. Now they have like cargo netting there. So again, that's a safety feature that has developed over time. But unfortunately, it seems that we kind of just, especially in public safety, fall behind. We're very reactive as opposed to proactive when it comes to new design and safety features. Obviously, emergency response is definitely an issue that can have line of duty deaths. So some things that are out there. We have evolved from flashing lights to rotating lights and strobes to light emitting LEDs, and sirens have also become more efficient and provide a wider range of frequencies. So we're doing things to try to make our ambulances more visible. You can look at an ambulance or a fire truck that is the newer ones, and they have that like DOT reflective striping on the back, so to help better illuminate them at night on the side of the road. Now, when we're looking at response, and now we're having fire trucks and ambulances that are kind of being GPS so they can get closer dispatch. What about having the technology when you see these two entities come together on a screen or getting close, that it does a warning, a proximity warning, or something that like Lone Star, where it cranks your car or unlocks it? What if it shuts them down to prevent the accident? Now, many intersections have installed cameras to signal traffic lights or monitor traffic flow. Is it possible that these cameras will serve an even greater function for emergency responders in the future? Is it going to be a way that, hey, the officer or somebody in the fire truck can monitor conditions of an intersection to make sure everyone has staff? So I don't know. There are all kind of possibilities out there. Now, crash investigation. One of the future applications of existing technology is the addition of event data recorders, or essentially those black boxes. And a good thing about these black boxes is the ability to collect data for crash investigations. And if we know the forces involved in the crash and what happened, then we could better come up with ways to fix the accident where there is technology out there to prevent injuries. And we can look at such things as speed, braking, acceleration, and even alarm if a driver performs an action outside the present parameters. So this could be a proactive approach. So this could reduce your vehicle wear and tear, help correct unsafe acts, and possibly prevent crashes. So yeah, if we get the black box and you don't think that they should go over 10 miles over the posted speed limit, and the speed limit is 55 in your jurisdiction, you have the ambulances or the fire trucks coming out at 65. Or something that, shuts down fuel flow if you hit 66. Something to keep these drivers in check so they're not, excuse the expression, driving like a bat out of hell. Now, believe it or not, falls is another significant portion of line of duty deaths. Many times this is the result from falling from a building or a piece of apparatus, or falling through a building, such as a burned out floor. Now, advances in safety will likely concentrate on two areas, and that is fall protection and eliminating the need to be in a position in which a firefighter can fall. An example of this would be falling from an apparatus, and I personally know a firefighter that was on top of a fire truck and was loading hose and loading the hose and focusing on that, and took a misstep, fell off a fire truck, injured his back so severely that it damaged disc, and actually had to retire from the fire service, was on disability because of it. So now, with falls from the apparatus, it is a safe assumption that most falls from an apparatus are preventable. And in most emergency vehicles are equipped with seat belts, and the proper use virtually eliminates falls from the cab, from the old days where you had the cab overs, where people were exposed to the outside elements, didn't have to wear seat belts and things of that nature. Now, a large diameter hose, is one example in the fire service that is begging for a better solution. Now, we have gone from the smaller hose to this large, heavy 5-inch hose, which, it's good in the sense because it provides an unlimited flow of water. It's like taking the fire hydrant and, moving it directly to the fire, for lack of a better term. So it's a good thing to have, but our way to store it isn't. And an example of that is, you look at this 5-inch hose. It's heavy. It weighs a ton. How are you going to load it on the fire truck? And, we put people on top of the fire truck. You've got 3 individuals, loading it if you're lucky, and maybe backing the fire truck up over the hose as you load it. Well, that's not necessarily a good idea, because if you're not paying attention, somebody could get ran over. So what about a way to remove the couplings from the bed? And, what happens when those 5-inch couplings come out of the bed and hit something? So the way we store it just needs some work. And, the way we deploy it. So again, got any great ideas? Hey, this could be your way to make some money. Now, another example of fall death is falls from ladders and aerial devices. And many of our line of duty deaths occur while working from some sort of elevated height. Now, many contributing factors to falls have increased, such as newer aluminum ladders that are more slippery to climb when they're cold and wet. Residential building surfaces have changed from brick to vinyl siding or aluminum that doesn't stick well to vinyl. And our ground ladders use has changed for firefighting. And we're using them more hastily. Now, changes in ground ladder design might concentrate on the way to better use the ladder today, or a better way to keep them in position once they've been raised. Once you put them up, what's keeping them from sliding off these structures? Do we put a hook or a tether system at the top? We have somebody healing the bottom, but again, what keeps the feet from kicking out for some reason? Now, our aerial devices that we work from have really developed a lot of significant improvements in safety as a result of the better technology, but firefighters still fall from them. Again, why? Are we not using the technology? We've got these enclosed baskets on the top. Are they not tying off? I don't know what the answer is, but we're still having fatalities from it. Now, I'm not talking about the equipment failure, and of course that does happen. Hall County several years ago bought a new, I say new, it was a refurbished fire truck, aerial truck. And when they had crews out there training on it, something failed on this refurbished fire truck and caused the bucket that was elevated with people in it to basically collapse. And of course people fell out and got injured, and I think there was even a fatality with it. Another issue of falls is firefighters on the roof ventilating. Is there a better way to do it? As time passes, the roofs are getting thinner and thinner in terms of technology. If it's cold and it's wet, hey, you could slip off of them with the roofing material. So future technology could create a faster method of rooftop ventilation, hopefully. Now, another type of line of duty death is being struck by or in contact with other vehicles. Now, being struck by vehicles. Pedestrian alerting is an option. Automobile manufacturers are currently improving a pedestrian avoidance system in which a vehicle computer compares stored images of pedestrians and small animals with images of objects in the path ahead. High visibility traffic vests could someday give off warning signals that vehicles recognize as a specific hazard, causing them to shut down. Sensors mounted to the running board of fire trucks could be capable of sensing an object in the truck's path, setting off alarms. So, preventing backing into something or hitting something. A new tone of safety, green, was actually introduced, which reserving a certain color exclusively for pedestrians is a step toward reducing pedestrians being struck. Construction crews on highways have already affected emergency services in the form of their high visibility vest and those arrow stickers, as I said earlier, the chevron striping. Now, construction zones utilizes two more methods that we could adopt to reduce or minimize the effects of crashes by deflecting the energy exerted during a crash. An example of this is the concrete or jersey walls or truck-mounted impact annunciators, or basically crash cushions. A good example of pedestrian in terms of public safety getting hit. I know of a case where a firefighter was actually getting out of a fire truck and was struck by a police cruiser and actually ended up on the hood of it. So they were both responding to the scene. The fire truck stopped. The firefighter was getting out the back. A police cruiser came whipping around the fire truck. I guess didn't notice the firefighter, and of course he ended up on the hood. So, what is something that can prevent that? Another issue is being struck, of course, by equipment. Now, this category includes tools and equipment that fall or an unexpected movement that sometimes occur. Many of these injuries will not be prevented by technology, but proper training, situational awareness, and effective command and control could help prevent it. Now, technology can assist in some areas of equipment design, such as better helmets or reducing the hardness or things of that nature. Maybe some sort of pressure testing, whatever the case may be. Now, being struck by debris. We might look at a way to reduce our risk of being struck by debris in the same way that nuclear plants operators might look at reducing the risk of radiation. And of course, with radiation, they look at time, distance, and shielding. So the sooner we can get out of danger, the better the risk-benefit ratio is. Distance. Anytime we recognize a risk of potential energy, we should work from the furthest possible distance. And of course, the last way is shielding. So to reduce the risk from being struck by debris is to protect yourself. And new technology, advance in gear would definitely help with that. Flashover is generally considered the point at which all combustible materials in a room reach ignition temperatures at the same time. Technology similar to a rate of rise detector, which notices an increase in temperature, might be useful to help notify individuals of this current situation. Now, further research projects could take more environmental clues from sensors and advancing crews to forecast this dangerous event. Simulators. Now, we talked a little bit about the flashover simulator in Atlanta, and this is kind of where all this comes together. Now, simulators are one of the most promising uses of technology. The military and aviation industries have chosen three-dimensional simulators to fit their needs, and the fire service is on their way to following their footsteps. As an industry, it should be relatively easy to design simulators for firefighting due to the amount of gear and tools we carry. Simulators must be able to accomplish four things. Use realistic gear, reflect realistic movement, reflect a realistic, this is a big one to me, firefighting environment, and portray a realistic response. Being caught, trapped, or lost is a big line of duty death. Now, technology improvements do not necessarily have to be in the form of new equipment, but they could also concentrate on improving the existing technology such as the pass alarms or pass devices. Collapse. The Chicago Fire Department did partner with NASA to research the belief that buildings undergo a signature change before they collapse. If sensors could detect the change and give ample warning, your ICs could have the information that they need to make informed decisions about, getting folks out in time. Robots. Robots can open doors, climb steps, and drag equipment. It is only a matter of time before they are introduced as another tool for firefighting. Robots could scan for victims possibly. And another obvious application for robots is in the pump panel of a fire apparatus. So the more AI we develop and use, the more applicable it could be in terms of helping us with firefighting. Communication. It always seems that anytime there is a fatality or an injury, one of the main components in the investigation is cited as a reason for potential cause of the incident is poor communication. Now, when we're looking at communication inside of a structure, that can be kind of hard. So, what about technology out there of being able to have crews talk and be able to communicate? Some sort of one-way, two-way walkie-talkie systems mounted in our face masks along with the thermal imaging cameras, I don't know, but something better than what we have, and not only being able to talk to each other, but other responders. Not necessarily inside a fire, but on scene. So interoperability between agencies or mutual responding agencies, like a city and a county department or police, public works. So we definitely need to work on our interoperability. That way we can all communicate effectively, and I think we're getting there in terms of satellites and certain radio bands and frequencies. I just think we've got to start bridging the gap between, the police and sheriff and EMS and fire having their all own separate frequencies and not sharing, frequency channels and things of that nature. All right, so conclusion. Technology is a vital layer of protection that does have limitations. However, little common sense. Technology should not replace good skills and techniques. It should only enhance them. We must insist on rigorous testing and consider the application to emergency service. The new technology must be trained on and used in conjunction with other tools that we have to provide an effective system. Technology does not compensate for bad decisions. Technology, however, will likely change tools available for us. When we review line of duty deaths, it tells us what technology might provide it in the future. Example of that is stress and overexertion, reduced through better medical monitoring. Motor vehicle crashes, better equipment for safety and falls, better equipment to prevent responders from being struck by vehicles and falling debris. Developing warning devices on fire gear to improve safety and fire dynamics, as well as simulators for safer training. Technology to focus on collapse warning systems to prevent firefighting and getting caught or trapped. And improve communication with new radio systems with built-in intelligence. Okay, gang, so that pretty much sums up Chapter 8. If you have any questions, you can email me at aroberts@athenstech.edu. Make sure you do your online review questions and start boning up, getting ready for your examinations if you already haven't taken them. For those of you that are listening in on this YouTube video, This is a fire science program at Athens Technical College class that is available online for those individuals interested in getting their associate's or diploma in fire science technology. Okay, gang, until next time, be safe and have a great shift.